Good morning to all. Myself, Dr. Jayapal, Assistant Professor, PG and Research Department of Computer Science and Artificial Intelligence, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. Circuit switched network. A circuit switching creates a direct physical connection between two devices such as phones or computer. The left hand side we are using the ABC devices. The another side we are using the some devices like D, E, F and G. The both side devices we are connecting through the switches. The switches we are using here one, two, three, and four. So we are made to connecting from left hand side to right hand side through the switching. So that is one simple diagram to how to make to connecting the both sides of devices by a circuit switched network. The first one is a circuit switch. A circuit switch is a device with n inputs and m outputs that creates a temporary connection between an input link and an output link. The number of inputs does not have to match the number of outputs. Here, as per diagram, we are using the left hand side, the 1, 2, 3, and number of devices we are connected in the left hand side. So likewise, we are connecting the so many devices 1, 2, 3, and then up to M, the both sides. Okay, the first one is a circuit switching. A circuit switching we are classified into the main two switches. One is a space division switching, another one is a time division switching. The space division switching it's having the two types. One is a crossbar and multi-stage. It's already we are going to discuss. The time division switching already discussed in the previous one. The same division switching, space division switching. In this, the pattern in the circuit are separate from each other spatially. A type of switching system in which all of the link, contacts, matrix, cross points, and switches are physically separated. This technology was originally designed for use in analog network, currently used in both analog and digital networks. The first one is a crossbar switch. A crossbar switch connects N inputs to M outputs in a grid using electronic magnetic switches, that is electronic micro switches, that's called the transistors at each cross point. The major limitations of this design is the number of cross points required. The connecting N inputs to M outputs using a crossbar switch requires a crossbar with 100 cross 100 means we need the 100 crossbar switches. So in this factor makes the crossbar impractical because it makes the size of the crossbar huge. So that is a diagram for the crossbar switch. So as per diagram, we are using the left hand side three switches and bottom side we are using the four switches. We have to make to connecting from left hand side to bottom side, that is a 3 to 4 means we need the 3 fours are 12 crossbar switches we need to make to connecting the both sides of the devices. So here, so for example, suppose the 20 inputs and the 20 output devices means we have to need the 400 crossbar switches. The 400 crossbar switches means it's more expensive, and then it's a fault identification and isolation, and the cost wise it's more expensive in these crossbar switches. These drawbacks you have to overcome in the multi-stage switch. And the second one is a multi-stage switch. The solution to the limitations of the crossbar switch is to use multi-stage switches, which combine crossbar switches in several stages. In multi-stage switching, devices are linked to switches that, in turn, are linked to a hierarchy of other switches. So that is the diagram for the multi-stage switch. We are using the different stages, stage 1, stage 2, and then stage 3. The stage 1, we are using the three switches. Stage 2, we are using the two. Stage 3, and then 3. So totally we have 15 inputs and the 15 outputs. The 15 devices we are connected to the 15 other side devices by using the different stages. Actually, generally we are using the 15 devices to 15 devices means in crossbar switches, we need the 225 switches. But here we are using the multi-stage switches means we need only the 78 switches enough to connecting the 15 to 15. So the stage one, that is first switches is the five inputs and two outputs. That is a five twos are 10. A 10 crossbar switches is enough in the stage one first switch. Likewise, the series three switches means 30 switches enough in the stage one. The stage two, the three inputs and three outputs in the switch one, three threes are nine. Likewise, the another one nine. Totally 18 switches enough to the stage two. Likewise, the stage three, it's the as it is we are using in the stage one. That is 30 switches. It is in the stage three. So totally how many switches we need to connecting the 15 to 15 means 30, 18, 30 means it's only enough to 78 switches to make to connecting the both sides of devices, the 15 into 15. Here we are reducing the crossbar switches in the multi-stage switch compared than the crossbar switch. So the design of a multi-stage switch depends on the number of stages and the number of switches required in each stage. For example, imagine that we want to multi-stage switch to do the job of a single 15 by 15 crossbar switch. Assume the three switches in the first and final and two in middle. Each switches has five inputs. Each 5 cross 3 equal to 15. There are two intermediate switches. The intermediate switches must connect to all three first stage switches and the all three last stage switches. And so much we three inputs and three outputs each. How to make to connecting the one side to another device by using the multipath in the multi-stage switch. So that is a multi-stages switches provide several options for connecting each pair of linked devices. The two ways traffic can move from an inputs to an output using the switching design. A pathway is established between input line 4 and output line. So in this instance, the path uses the lower intermediate switch and the switches center output line to each the last stage switch connected to line 9. So there is a diagram for the multi-path switching. So that is a left hand side we are connecting from 4 to 9 means the stage 1 the first switch is connected to the stage 2 second switch, and then the stage 2 second switch is connected to the stage 3 second switches. The second switches is make to connecting the 9 to 1 devices. So here 4 2 and then 9 we are making connecting the multiple path switches we are using to connecting the both sides of switches. Thank you.